Hey guys, okay, so today we're going to cover dimensional analysis. This is going to be just a little quick snippet. Um, I think math is probably one of the most important aspects of veterinary medicine that you can learn, and dimensional analysis will always get you through the problem. So we're going to start off with what is dimensional analysis. Dimensional analysis, just the easiest way to remember it is it's a process of cancelization. Whatever conversions that you have, you want whatever your answer needs to be, the last conversion that you have not canceled out throughout the whole process. So for example, just like the video that was already posted in Blackboard, we know that 1 kilogram equals 2.2 pounds. If you have an animal that is 55 pounds, and we need to convert that into kilograms, you're going to start with that weight, 55 pounds. I draw my dimensional analysis differently than that video, and I think this might help out. We always know that when we have a whole number that it really is 55 over 1. And then we want to do our conversion, and because whatever's on top, if the same thing is on the bottom, that's what's going to cancel. So we know that we're going to put 1 kilogram on top and 2.2 pounds on the bottom. Now this is the universal sign for pounds. I get a little worried about doing the 1 kilogram equals 2.2 lbs because a lot of people get this L mixed up with a 1. So we want to make sure that we're not getting that confused. Within that video that I've already posted, you know that we can keep going with this dimensional analysis. We don't have to stop here and then convert MIGs, to KIGs, that kind of step by step. We can do it all in one. So the information you're going to get from a veterinarian and from your physical exam on the animal is you're going to start with the animal's weight. So, when you go into a vet clinic and first thing they do is have you take your dog to step on the scale, it's really important because that's what's going to give us the best calculation for the medications that they need. So this animal weighs 55 pounds. Then, which we haven't gotten to yet, the medications. Let's say this animal needs a medication and the veterinarian says, please give this dog 1.1 mgs per kg. So we're going to write that down, 1.1 milligrams per kilogram. Okay, this is the prescription. This is the veterinarian has to give you this. We cannot do this as technicians. So that's the prescription. Then the next piece of information that you're going to need is the concentration of the medication, of the drug. That will always be listed on the bottle or on the packaging of that drug. So when you look at it, it's going to say, let's say it says 10 milligrams per milliliter. So on the bottle, you're going to actually see the name of the drug, whether that be the trade name, and then you'll see the generic name underneath it, and then you're going to see the concentration. And for this drug, we're going to say it is 10 milligrams per milliliter. Okay, we need these 3 pieces of information to actually administer this medication to the animal. So we're going to start our conversion or dimensional analysis. So like I said, I put mine in little boxes so that right now if I stopped, I would have this animal's weight in kilograms. The next piece of information, we can see this, which is our prescription at 1.1 mgs per kg, has kilograms in it. So then what we're going to do is add 1.1 milligrams here per 1 kilogram. So you can write the 1 in there. If I stopped right here, I would have the total amount of milligrams administered to that animal. This is really important because this is what you're going to write in the medical record. Because drugs come in different concentrations, it's important to write the total milligrams because then it doesn't matter what the concentration is of that drug when you write it in the medical record. That's the total amount of drug administered. Now, the total volume of drug administered is what we need to draw up from our bottle. So the next piece of information we have is that concentration. And remember, that is on the bottle. We're going to put our 10 milligrams on the bottom because that's going to cancel, and the 1 milliliter at the top. Okay. Now we can take our calculator and we can just type in straight across multiplication and straight through the bottom division. You can also do 55 divided by 2.2 multiply 1 by 1 divided by 10, but it's just easier if you just go straight across and straight through the bottom. So 55 times 1 times 1.1 times 1 divided by 10 divided by 1 divided by 2.2. Okay, then remember, your pounds cancel, kilograms will cancel, milligrams will cancel, and look, we're left with milliliters. If you put that into your calculator, I have to look because it's 2.75 milliliters. The next thing that you need to know for administering medications to an animal is, can you draw up 2.75 mLs in a 3 ml syringe? Probably. Most likely though, you're going to draw up 2.8 mils. You always have to put this back into what tools do you have, okay? So most 3 ml syringes, you're only going to be able to go to for every 0.2 milliliters. So you'll have to round accordingly, okay? Do not round to 3, do not round to 2.5, you round accordingly. You can draw up 2.8 mils, and sometimes certain medications, that therapeutic range is very, very small, and so 2.8 mils, it's really important to be that accurate, okay? Now remember, I said you're gonna have to write in the medical record. If you write, I administered 2.8 mils of a drug, let's say called xylazine, somebody may ask you, was that 10 mg per mil or was that 100 mg per mil xylazine? So that's why it's important to make sure that you put the total number of milligrams in the medical record. So if we stopped here, remember what I said. Instead of adding the concentration, that's going to give you the total number of milligrams. So then we would take 55 times 1 times 1.1 divided by 1 divided by 2.2. And we end up with 27.5 milligrams. Now, if we're administering 2.8 mils, remember, you're going to have to round that to 28 milligrams total. Don't write 27.5 because you actually administered 2.8 mils, which is 28 milligrams. If you had 100 mg per mil bottle instead, remember that would change this a lot, okay? So it's really important to make sure that you follow through with this dimensional analysis. Make sure you reach out if you have any questions.